Okay, I hope my screen is visible.
Yes.
Yes, visible.
Okay, okay. So what I will do, I will open a new document. So in the CNN part, okay, that day, what we had covered, and I will refer to the document also because there is some confusion in the document. The document which has been shared, it is absolutely correct. There is no problem in that, but it has got a lot of mathematical notations. So I will cover from your quiz point of view that how to solve it fast. Okay. So we take a CNN for example. I will just take a simple example. 1, 2, 1, 0, 0, 1, 1, 0, 1. Filter K is equal to 1, 1 minus 1, 1. Stride is equal to 1. Suraj, am I audible?
Yes, you are audible clearly.
Okay. So see in a CNN layer, what do you have? You have got an input layer. Then you apply a filter, you get an output of that. Now here you can have a ReLU, you can have after ReLU, you can have a max, and generally what do you do after that? Again, you apply a sigmoid or softmax. So this is your output layer here, which is there. So let we denote it as A, B, C, and D, and we take this concrete example. This is 1, 2, 1, 0, 0, 1, 1, 0, 1. We apply this filter. So if you apply this filter, so here it will get applied. So this will become 3. It applies here. This will also become 3. You apply here. So only one part is contributing -1. You apply here. Only two parts are. Now when you apply the ReLU on this, only the positive elements they pass through. So 3 will pass, 3 will pass. It will become 0. This will become 2. Now you apply a max on this. So when you apply a max, so only 3 will come. You apply a sigmoid on this and sigmoid of 3. Suraj, can you calculate? Okay, please. Can you give me sigmoid of 3?
Yeah, let me calculate.
Yeah, I just find out. So this is 0.95. Okay.
Okay.
Now, when you do in a CNN backpropagation, it has got three distinct parts. Three distinct parts. What does it have? It has got one part at the output layer, like we used to do in the artificial network. So I want to find d dou of loss at dou d. And thereafter, I want to come here because here is the convolution, and I want to find dou.
Yeah, doubt actually,
Yeah.
like how that B 3 3 minus 1 2 alone.
See, you applied this filter. So you take this filter 1 1 minus 1. You
Okay.
put it here. So
Okay.
1 into 1, 2 into 1, 0 into -1, 0 into -1. So 1 plus 2, it becomes 3.
Okay. Okay. Got it.
Okay.
Got it. Got it.
So how do you do? You apply first filter here, second filter here, third
Yes.
filter here, and
Yes.
fourth filter here.
Got it. Got it.
Okay.
Thank you.
Now when
The
you do the back propagation, for example here, yeah,
second value would be 4, I think. 3, 4 minus.
hello, which one?
They are saying first row is 3 and 4.
Hello.
No, it will be 1, 2 or 2, 1 will be same.
See, this is the first one. So it is 2, 1,
Yeah, there is a 1.
3.
There's a 1 at the bottom. Yeah,
Yeah.
Yeah, second
Okay.
one will be 4.
Now
Yeah.
second one.
we, so yeah, it will be.
Yeah,
You're right.
second row has a 1.
Okay. Okay. Now it's a very good example to check it. Now when you, for example, you have been given true y is equal to 1, loss function is MSE. Generally for the sigmoid it is MSE only, y hat minus y square. Now when you do the what we want to update, we want to update k. So we need a del L by del k. Okay, that is our objective. This we can write as del L. Here is this y hat by del y hat, del y hat over del d, del d over del c, del c over del b. So this, and here del b over del k. This we can write. This is okay. Now this we get
Okay.
y hat minus y. This is a sigmoid because y hat is equal to sigmoid of d. So this will become y hat into 1 minus y. So this is the output layer we have covered. Now depending on the activation function in the output layer, this is first part we complete. Now in the second part, when you come, now depending, it might be, somewhere okay, it might be average, sum, max, relu. But what is the logic how to reach del L by del B? Now see here, only the max element 4 is contributing to the loss. No other element is contributing. So here you make this as 3 0 sorry 0 0 1 1. Is this clear? This particle, oh sorry, 0 0 4.
Yeah.
Now when you come here in the relu, 0 0 will remain 0 and this will become 0 0 4 0. So what we have achieved, these numbers we can write. Y hat is 0.95 minus 1, 0.95, 1 minus 0.95, and here we have reached 0 0 and 4 0. So only my this neuron which is there, it is contributing to the loss, and this last part del B by del K, it is nothing but A. So you will get something like A, and for example, this number becomes, it will be a very small number, 0.04 if I am not wrong, 0.04 into 4, so 0 0 0.16 is this figure. Now just as a shortcut, whenever there is a stride is equal to 1, then to get del L by del K, you just do convolution of input matrix by this, and you will get the del L by del K. But this is valid only for a stride is equal to 1. So if you do now this, so it will come here, it will become 0 0, and here one term will come 0.16 into 2. This becomes 0.32. You apply it here, you will get 0.16. You apply here, you get 0.16. You apply here, you will get 0.16. So this you have got now del L by del K, and now you can update your L, K is equal to K minus eta into del L by del K. Is there any doubt up to this step? Anyone?
No doubt.
No.
Okay. Okay. Now I will cover the part of what I've shared in the group also, that how to do with the stride of 2. So in a convolution, I will slightly cover like this. I will take the same example now. 1 2 1 0 0 1 1 0 1.
Zero zero one one zero one.
And what was the K?
1 minus 1 2. Yeah, 1, correct.
Now, if your stride is different, so what you have to do for a single stride, your B was, see, if you start from 1, 2, 3, 1, 2, then this is A11 into K11 plus A12, K12 plus A21, K21 plus A22, K22. Is this clear? This is a convolution operation which we have done.
Yes.
Now here also you write down the same things, and here you get A12, A13, A21, oh sorry, A22 plus A23. Here also you write down. Here it will become A21 plus A22 plus A31 plus A32. Here. So see which are the elements which are contributing. So finally, what do we get here? For example, this is B11, this is B11, this is B12, B13, this is B14. So if you have to take del by del K, it means your del B11 will be has 4 elements. Is this clear? This one. Similarly, your del 1, 2 will have 4 elements.
Yes, correct.
Similarly, third will have 4
4
elements,
elements.
and fourth will have 4 elements. Now, if you have got, for example, del B, del L by del B, you got 4 numbers. Like in our example, we had got 0.01600. Now, how did we get that this convolution? I said that for a stride is equal to 1, directly you can do the convolution of A by this filter. Because here I know when you do del B11 by K11, you get A11, here you get A12, here you get A21, here you get A22. Because these were the 4 elements which are contributing to B11. Okay. So what you do, you apply this, you multiply these 4 numbers by A11, A12, A21, A22, and you will get the first element. Okay. For the second element, you multiply this by the second row, B12. For the third, you multiply from by this, which you are getting. And for fourth, you multiply by this, and so that you get the convolution. Now taking this concept further and forward, if your stride becomes 2, so I will take the example of your GA. Can we take that GA question? Because there is a lot of confusion about that. Shall we solve it okay from the starting?
Yes, sure.
Yeah. Okay. I'll open that. And anyone having any doubt, okay, you can stop me in between. So today I have kept okay, basically to okay, this is the question. Compute the convolution, choose the output dimension, enter the sum of given. Now in the question what they have done A1 is equal to x convolution k, number 1. Number 2, they have done matrix through a sigmoid function. So now they have done h1 is equal to sigmoid of a1. Then they have done flatten the matrix, take the sum, and y hat is the sigmoid of the sum. Y hat is equal to sigmoid of h1. Lovely, is it making any sense to you? Okay, till now?
Yes, yes.
Yeah. Okay. So see, this is our convolution layer. This is our input. We apply a filter K. We get some output A1. Then on that, we are applying a sigmoid. We are getting H1. Now H1, this is sum of H1. Sorry, this is my is equal to sigmoid of sum of H1. Here we are doing sum of this H1. We get some number, sum. We apply sigmoid, and then we are getting a y hat. Okay. So what we can do, we can make a forward pass. And in the question, stride is equal to 2 has been given to us. So if we do a forward pass by this 0.061, 0.2, first it will come here. So here this will become 0.8. It is stride 2, so it will come here. So 2 into 0.6, 1.2 plus 0.4, 1.6. And again we get 0.8, 1.6, because now it will come here because stride is equal to 2. We take the sigmoid of this. So sigmoid of this had come around 0.69, 0.83, 0.69, 0.83. When we did the sum of this, it came around 3.04. And we took the sigmoid of this, it came 0.95. And in question, y has been given 0.1, loss has been given MSE. Okay, this is the question. So forward pass we have done. Now we have to do the backward pass.
Hi Lalit, one doubt.
Yeah.
Yeah, why did we skip the 0, 0 layer? Is it because of the stride to like vertically also we
Yes,
skip?
yes. See, the first stride we got this, then we went second stride. Now when we do the vertically also, this stride is vertically also. Okay?
Yeah, got it.
Okay. Okay. Now, so what we have to do with the backward pass, let's call again, okay, like this is A, X, okay, sorry, in this case, this is A1, this is H1, this is sum of H1, this is sigmoid. So if you consider where will be your output layer, where I'm having the output, I'm having output somewhere here. The sum is coming and my output layer is here. Let's call that as K2. So I have to update K, so I have to find del L by del K. This I can write as del L by del y hat, del y hat over del A2, del A2 over del H1, del H1 over del A1, del A1 over X. Is this correct here? Now in the document which has been shared with you, what it is, it says that when you do del A2, A1 by H1, so you get a big matrix. And what I said that I'm giving you a shortcut to get a solution fast. So let's take a start. So this is my output layer till A2. Del L by del y hat, we will get y hat minus y. This is a sigmoid layer. So here I will get y hat into 1 minus y hat. So this part I have covered, output layer. Now see, when the loss flows back, this 3.04 number which is coming, it is coming from all the elements. It is coming from 0.69 also, 0.83 also, from this also, from this also. So this loss will flow from all the elements, unlike ReLU or unlike Max. So here all the elements are participating in the loss. Is this clear, okay, to everyone?
Yes, it's clear.
So your del A2 by del H1, it becomes 1 because everybody is participating. Okay, whenever there is a sum, then it is 1. Now we come to del H1 by A1. H1 is equal to sigmoid of A1. Therefore, we know del H1 by del A1 will become H1 into 1 minus H1, sigmoid derivative. So this we can write here 0.69, 1 minus 0.69. This will become 0.83, 1 minus 0.83, and the same figures will come here. This is clear? This one. And now we reach here del A1 by del X. Okay, this I will cover later. I write here del A1 by X. Now all these numbers we have got. Y hat we calculated 0.95. Y is 0.1. Y hat is 0.95. This is 1 minus 0.1. This I calculate, so I get these numbers. And here I do del A1 by del. This was del T. Now finally, if you calculate this
So 1
number,
minus 0.95, right?
yes,
1 minus 0.95, right?
yes.
0.95. Now fine. Good. Correct.
So here, if I remember the calculations, it had come 0.084, 0.0056, 0.0084, 0.0056. So this we have, this is your del L by del A1, and here is del A1 by del K, and this is your del by del K. Is this clear till now, everyone?
Yes.
Yeah. Okay. Now is the part here for the stride is equal to 2. So I'll copy here. Now what you have to do in the stride 2, you have to find which are the elements which have participated for B, for A1. So let's write A1 is equal to stride is equal to 2. So let's denote 1, 2, 3. Let's denote this as 1. So for the first element, only this x11 k11 plus x12 and k12 participated, and here participated x13 k11 plus x14 k12, and here participated was x31 k11 plus x32 k12, and here x33 k11 plus x34 k12 participated. So when I do, I have to find again in the calculation del A1 by del K. This is my last part, which I was interested. Okay. Now for stride is equal to 2, I cannot do directly convolution. Here I have to find the elements which are participating. So let's call this as, if I call it as a, other than A, if I call it as B, for example, because then it becomes slightly, this is B11, B12, B21, B22. So when I do del B by del K, I have to find del B11 by del K11, del B11 by del K12, del B11 by del K21, del B11 by del K22. This is for del B11. Similarly, I have to find or del B12, 12 del K11, del B12 del K12, del B12 del K21, del B12 by del K22. For this element also, I keep on calculating. So here, if you notice, I will use different. Del B11 by del K11 is X11 and X11 is 1. Del B11 by del K12 is X12, which is minus 1. Del B11 by del, there is no K21, so it is only this. That will complete full. This will become del B21 by del K11, del B22, B21 by del K12, del B22 by del K11, del B22 by del K12. And let's find which are all the elements which are participated here. So here, for del B11 by del K11 is X11, which is 1. For K12 is X12, which is minus 1. Del B12, which is this, by del K11 is X13. X13 is 2. Del B12 by del K12 is X14, which is minus 2. Del B21 by del K11, you see here, we have K11, so this is X31, which is 1. Del B21 by K12 is X32, which is minus 1. And here you will get X32, which is K12, K11, sorry, X31.
It's 2, right?
Is X3, X33, which is 2, and here you get minus 2. So these are the elements which you have got. So now, if you write down them, so when you will do del L by del K, and you
Yes,
had
one
got,
doubt.
for example, this.
If in the H matrix,
Yes, yes,
if it is instead of in that
yes.
second row, instead of zeros, if some other values are present, then it will be participated, right?
No, for the stride 2, this is not participating because in vertical, you made one stride. So this row has not participated at all.
Okay. If it is stride 1, it will be participated, right?
It will be participate. In the stride 1, it becomes very, very easy because then whatever you get, you do the convolution on
Okay.
X and you get the answer.
Okay.
Okay.
Yeah.
Only for the stride 2, you do this because now you're trying to find which are the elements which have participated.
Okay.
So this was 0.084, this was 0.056, 0.084, 0.056, and here you got these numbers which you got. Okay. Now what you do in this convolution, this number which are there 1, 2, 3, 4, you multiply by this. Okay. So your first element will become 0.084 into 1 into 0.056 into 2 plus 0.0084 into 1 plus 0.0056 into 2. So this again you got here. Second element which you are getting, you know that dimension of this del L by del K is same as K, and K dimension is how
Yes.
much? 1 into 2.
Correct.
The second element which you will get, it will be 0.0084 into, take the first element which is minus 1. Okay. Plus 0.0056 into minus 2 plus 0.0084 into minus 1. plus 0.0056 into minus 2. So see, all the figures are same. Here it comes 0.0392 or 96 something, and here it will come minus 0.0392. And with this, okay, when you do the your updation, n has been given 1. This was 0.6. This was minus 0.2. Now when you do this, here from here you get the answer that answer in the range. And this will become 0.608. So this is how it has been done. In your quizzes, hopefully till now in the quiz, strike 2 has not been asked. And generally in the PyTorch, what happens, all this convolution and derivative of this convolution, it happens, it is programmed in the algorithm. Just for the understanding part, I wanted to cover today here that straight away it is not a convolution. Okay, in a stride 1, it is straight away convolution you can do. So in quizzes, most likely in all your questions, stride 1 will come. So that we have seen that stride 1, when we do, like I covered here, stride 1. So when we do the stride 1, it is straight away that you do whatever you get del L by del A1, and then you do convolution of the input layer by that, you will get your del L by del K. But if stride is 2, for this particular question of your graded assignment, I wanted to cover here. Anybody having any doubt till now?
No.
Hi Anand, good evening. Hi Puneet, good evening.
Very good evening, Lalit.
Hi. Hi Anand, is it clear now? I hope I made some sense. Lovely, is it clear? I'll share this document also, and I have posted on the WhatsApp also.
Yes, it's clear.
Yeah. Chalo, then if there is no doubt, thank you. Thank you so much for your time and patience. I'll take your leave.
Thank you. Thanks a lot.
Thank you.
Yes, Lalit.
Thanks.
Thank you.
It was
Would it be
helpful.
possible
Thank
to
you.
share the recording also?
Yes, Puneet, I will share. I'll share on the
All right.
WhatsApp.
All right. Brilliant. Thank you. All the best.